I mean, this is the scheduled start time here, as of now.
So, DKG, your audio is a little low here. I'm not sure if that's adjustable or.
I can probably adjust it. I can also probably just not mumble.
Oh, okay. Not mumbling seemed to work.
Great. Falco, thank you.
Thank you, Falco.
Stephen, are there birds in your lab?
The window's open and birds do tend to congregate on the roof nearby.
Nice. Nice. Okay. Just thought that might be an unusually squeaky computer, but glad to hear it's birds.
It is birds, yes. If they attack me, I'll turn off the video, don't worry. Neil, thank you also for being willing to back up on notes. That's great.
Yep. So I figured we give a couple more minutes for people to come in. I see that we have everybody who is intending to present here, which is good. Not sure who else is likely to join.
Hello. I would have a brief, like a slightly updated version of the slides rather than the one I sent you the other day.
Okay. Can you upload that to the meeting page, and then Stephen and I can click the approve, and then we'll click the refresh button here, and maybe it will work.
Okay, so let me see. Where do I do this?
The meeting page is. There's a link in the chat there to the meeting page. If you click upload, then I can probably click approve. Or if you want to just mail it to me and Stephen, we can probably do that too.
I can't really. No, okay. I see.
So DKG, I'll pass you the slide control if that's okay.
Sure, that's fine.
Since you did the work of making them, I guess.
That sounds fine.
Okay, I should have uploaded the slides.
I see an email.
Okay, I see it.
I'm in the process of hitting the approving button.
And then I suppose we should probably remove the old one. We can't really version it now. Right? Because the original one we uploaded as opposed to, hey Bart, I see you there.
Yeah, we can delete it later. So it's the last one is the recap one that we want to use today, right?
Yeah, as opposed to the one that I titled post-quantum photography. So I'll put this in the right order.
So let's leave it there just for the moment. We can delete it later.
Okay. There's some way to refresh the materials, I think, here, but I don't know how to do that. I'll figure it out later. So I figure.
Refresh. I'm hitting the refresh. I guess you can fire ahead with the chair slides, TKG.
Yeah, we'll start that now. It's for 5 minutes. We're giving folks 5 minutes to join. So welcome everyone to the interim meeting, May 2024 for OpenPGP. Just a few things to consider here. This is the usual IETF note. Well, this is an IETF meeting. Discussions here are covered by IETF policy. You probably have read these things if you participated in IETF in the past, but it's just a reminder. Think about intellectual property and concerns about how the working group operates. Remote meeting tips. If you're in a meeting, we encourage you to have your video and audio off unless you are chairing or presenting, or if you're speaking from the queue. We encourage you to use a headset if you can. And if you want to speak, you can add yourself to the queue. If anyone wants to try adding yourself to the queue, if you're not used to MeetEcho, now's a good time to do that. It's a little hand button in the web interface for MeetEcho. And there's a text chat going on. We encourage you to follow the text chat and to leave notes in there. One more reminder, aside from the intellectual property policy concerns, is just the code of conduct concerns. We want to communicate clearly, avoid personal animus, and avoid unnecessary jargon. And if somebody needs clarification, we encourage you to ask for clarification. You are not the only person who probably needs it. If you're confused, we are all confused. The agenda for today is pretty straightforward. We want to briefly touch on the status of the crypto refresh, which has been progressed. Aaron Whistler, I believe, will present on the status of the post-quantum cryptography work, which is work group material. And then we have a discussion of two drafts that we are considering for adoption, but have not. I don't think the discussion on list has really reached a consensus. So maybe we'll have an opportunity to think about how we push those forward. And if the answer is the work group doesn't have consensus, we can also maybe talk about that too. Andrew will talk about the replacement keys draft, which he and Daphne Shaw have been working on. Daphne has been working on it since 2001. And then Daniel Huygens will present on the persistent symmetric keys draft. So if anybody wants to throw any other wrinkles into the agenda, now is a good time to do it. And at the end, we'll also have an opportunity for other business if people want to mention it.
And I think we're set for 90 minutes today is the meeting time, right?
That's right. The meeting is 90 minutes. If we manage to cover everything faster than that, that would be great. We can give everybody some time back. But it's a 90-minute session, so if you're presenting and your presentation goes longer than about 20-25 minutes, we might encourage you to speed it up. All right. So on the crypto refresh status, I just wanted to mention that as of last week, the draft went into the auth 48 state, and we have an RFC number that has been allocated that this will be assigned to, assuming we can get it out of auth 48. It will be RFC 9580. The review from auth 48 is quite large. It is proportional in size to the draft, which itself is quite large. There were like 64 questions, some of which were quite complicated from the RFC editor. And to get out of auth 48, maybe Stephen, you can speak to this a little bit more clearly than I can, but my understanding is that all of the authors, all of the listed authors will need to respond to the review. So if you are a listed author, please take some time to work through those 64 questions. You should see that at least Paul Wouters has responded to, I believe, all of them. But we need all of the authors to confirm that the clarifications the RFC editor wants to make are correct. Stephen, anything else to add to that as a process point?
No, I think that's it. It's auth 48 on a long document can be tedious. But should be non-controversial but tedious.
Yeah. Most of the changes are about clarifying terms and adjusting the width of things that are too wide and for the text formatting, things like that. But they're still there, and there's potential to make things worse to make the document harder to use. So please review if you are listed as a document author. I see we have most of the document authors on this call right now, but maybe not Nibe. I know this is a bad time for Nibe. It's in the middle of the night for him. So I will make a point to reach out to Nibe and encourage him to take a look at the review process. All right, so Aaron, are you up for presenting? I can switch to your slides. If anybody has any more comments on the crypto refresh.
Yep, all good.
I don't see the slides here yet. Your updated slides are not here. Let me see if I can poke.
I hit the update button, but it's just spinning on me.
Okay, so let me.
So the slides are in the tracker. So Aaron, you have them locally, and you can ask to share them, I guess.
Yeah, I mean, I can try slides.
Let's share slides, and where do I grant?
Oh, damn it. I still see the old ones.
It might be better to go ahead and share your new slides from your screen. Do a screen share, Aaron, if you're up for doing that. Looks like MeetEcho doesn't sync that well in a short period of time with the data tracker. So I'm seeing Aaron Whistler asked to share the slides, and I don't know how to reach that.
I tried it to refresh the page to see if the new slides appear, but I need to get permission again. No, I still see only the old ones.
Yeah, if you can you share the screen from local?
Okay, then I'll just share the screen exactly. Okay. Can you see this? Oh, I read a spoiler of the whole slides.
Yes, we can see it.
Perfect. So here is a brief recap of the changes that have been done between version 2 and 3. And then we're going to go through the open issues that we still want to tackle. I promised to have way less slides than last time. So we have this new algorithm list. We removed all the NIST and brain pool curves. We unparameterized SLHDSA. We kept only the shake version and in 128F, S, and 256S, as we discussed at the last IETF meeting. The draft with NIST and brain pool curves is still being created, is not yet there, but it will be a separate draft. So what we've done is a split of the two drafts plus a reduction of the SLHDSA. The algorithm numbers have been assigned for now for 105 to 108 to these algorithms because we do have implementations for them. While there is not yet a fully compliant SLHDSA implementation that we could use, so we are waiting to assign these numbers till we have a proper test vectors we can create. We updated the key derivation function. We moved the domain separation to the fixed information, and we also changed it so that tomorrow, like in the future, we can upgrade this and create a new version in case it's required. And we changed the key derivation function to use SHA-3 to 156 instead of KMAC. This simplifies the implementation, even though KMAC is, let's say, cleaner from the cryptographic side of this point of view. This offers the same security level at the same time for a fixed length output. That is all we need. So we make the implementation easier and simpler. Other minor changes we've done is we forbade the use of symmetrically encrypted data, tag 9, when you ever use PQC. I mean, no one should be using it anyway, but in order to make it very clear, we added a must not. We forbade also the use of insecure hashes when you use v4 keys with PQC components, so you can't use SHA-1 or MD5, as well as some minor references and editorial changes that we've carried out in the draft. These are the non-editorial issues that we still have open. They are also on our GitHub page. This is very, very like the second issue we had in the whole repository, and we have the following sentence: implementations must not encrypt a message to a purely traditional public key encryption key of a recipient if it's encrypted to a post-quantum key of the same recipient. Now, how is this must or actually must not be enforced? Like, how do we make sure that implementations correctly handle this? Like, there are several different types of implementations, some that are just a library, and those, should they look into the user ID, to determine whether it's the same recipient or not, or is it applicable to them at all? And this clearly brings to the next question, like, should we make it a should instead of a must? So like implementation, if they can, they should try to avoid this, but if they cannot because they do not have the appropriate context, they might not do anything about it. And then should we include some guidance into how to achieve this? Chairs, do you want to stop here or should I keep on going?
It's very much your call, but I guess it's probably easier if people want to join the queue to discuss this. We'll do so now, I guess.
Yeah.
So yeah. So if you're in the meeting and you have thoughts on this issue, please join the queue.
So, not speaking as a chair, but speaking as an implementer, if we think that must is reserved for things that will otherwise break the protocol, then I am not convinced that this is a must, because people will continue to be able to encrypt data and decrypt data. What it does do is it breaks the security of the protocol. If we say a should, I tend to think that we should explain what the exception is. And the difficult thing here is that I don't actually see any legitimate exceptions, other than I don't know how to do it because I can't tell which one is the right recipient. So yeah, I don't know how to frame this. And we could also just drop the 2119 language. We could say, if an implementation encrypts these both things, then the implementation is not providing post-quantum security as expected. But I don't know how to square this with the RC chain.
Note that is already included in the text. This note, like, if there's any recipient that is not post-quantum, the whole thing is not post-quantum. And this is in addition to this text, we have this other requirement that says, well, you must not do this mistake of, like, if it's the same recipient, because if you're already using two different recipients, and one doesn't have a PQ key, well, there's little you can do about it.
Andrew, go ahead.
Hi. Yeah, just to follow up on what the previous two people have said. Yeah, if you do have any non-post-quantum recipients, essentially at the application layer, it's a waste of time. So I'm not sure that specifically calling this scenario out is particularly useful or required, considering that we already have, as you say, guidance about, not encrypting post-quantum to everybody being an issue. In fact, I think it would be quite unlikely for an implementation to implement twice to the same recipient, or would it not? Are there implementations out there that would see multiple encryption keys for a single user and by default encrypt all of them? Is that common practice? And does it need to be specifically addressed here, or can we just live with the general warning against it?
As far as I'm aware, there's no implementation where it encrypts to multiple keys for a single recipient.
Yeah.
There is such a thing.
There is?
Yes. Emacs will encrypt a message to multiple keys for the same recipient if you tell it, here are the keys that I want to use. And the prompting for it is sort of encourages the user to pick all of the keys that they think might be useful for that user. Yeah.
So I think this sentence also put in context of our RFC is the fact that we suggest signing the same message for using a PQ and the traditional key at the same time. So this is the idea: is like, do this for signatures, don't do this for keys, for encryption.
Okay. Yeah, I suppose my question is really, does it need to be specifically called out in this particular case, or can we just live with the general admonition against not mixing post-quantum and non-post-quantum encryption? I'm not pretending to have the answer, just throwing the question in there. But thanks.
Stephen?
Yeah, so forgive a possibly stupid question, but where is recipient defined?
I don't think we define what a recipient is, actually. So
so I guess the issue is if we're going to have a must or even a should, it kind of assumes you know what a recipient is, and when two keys belong to the same recipient, and I just wonder, is we're obviously thinking of email in the back of our heads, but I don't know, do we need to have a better definition of recipient if we're going to have either a must or a should here?
True. We might want to make this non-normative then, as an idea, is the fact that we just say in the context where we say implement, like the fact that if you have any non-PQ recipient or any non-PQ key, then your message won't be PQ secure. And we might want to adjust the sentence saying, in the case of email, in the context of email, then try to avoid doing this.
Right. Or I guess the other way I'm not sure, I mean, that sounds reasonable. Another reasonable way might be to say that the first part you said about not encrypting to PQ and non-PQ keys, and then also to have some statement to say that applications using PGP, such as email, will have defined things like recipients. And in that case, this guidance applies to recipients. But I don't know. It's just I think we probably need a definition if we're going to keep language as is on the slide. Maybe DKG has a better idea if he's in the queue.
I was just going to mention that even in the chat, there's some confusion among the experts in the room here about what is a recipient, even from an OpenPGP level, right? Are we talking about multiple subkeys in the same certificate? Are we talking about multiple certificates that map to the same email address? Are we talking about multiple certificates that map to the same human?
Yes. So about the multiple subkeys, that case is clear. We say you should pick one, and it should be the PQT one.
Okay, and then I think outside of the OpenPGP context, we don't have like Stephen said, we don't have control over the recipients. So I think, I think the right approach here is to preface this, like Stephen said, with for context where there's some other concept of recipient besides certificate. If you know what a recipient is, then you shouldn't encrypt a message to two different flavors of key to the same recipient. But I think we've removed the 2119 language. We just make it not normative. And we say, if you think you know what a recipient is, then don't do this thing. And I think that would cover it without us, basically declaring, mandating something that we haven't defined. I don't think we should try to define recipient outside of same certificate in this draft.
And just to note, again, I think the word recipient is used multiple times in different places. So if we're figuring that we need to do something about it in this context, we might need to revisit that term wherever it's used.
Okay, yeah. Okay, I'll move on to the next slide if everyone's happy with this. At least.
So maybe Aaron, if you can just summarize what you think the result of the discussion is for the note takers.
Yeah, the result that I got from this is I'm also going to report it then back onto the issues, is to make the language non-normative, to specify that if the application layer knows the concept of a recipient, it shouldn't be encrypting to the same recipient with two different keys, one PQ and one non-PQ. At the same, and then in general, a review of the concept of recipient throughout the whole draft, if we have it anywhere else.
Thank you.
So this slide is about issue 101, that points out the fact that we have different security levels across the parameters we offer. In particular, issue 101 specified that MLCAM 768 is of level 3 and then SLHDSA instead is of level 1. That corresponds to 128 bits. We decided to represent this as a table instead because we would like to show the fact that this is also a problem, or at least an incongruence with the curves, because we match the 192-bit curve to the 128-bit curve. These are approximate, like this estimate saying 125, 106, but this is to give an idea of the range. The point where we would like to get is with MLCAM, we wanted to keep a security margin, and so we decided to go for 768 instead of 512, and same for MLDSA. So the question is whether we want to keep it this way or we want to lower the MLCAM to the 512. This would grant smaller artifacts and slightly faster processing time, even though they are already very, very fast. The artifact is instead, it changes by I think a kilobyte approximately across CAM and DSA. SLHDSA instead, raising this to the 192, it would increase significantly the size and the time for computation. So the question for the working group is, should we match these security bits, or are you happy with the status quo? And if we want to match, how? Andrew, please.
Yeah. I think the over provisioning of the MLChem is probably prudent, given that there have been concerns raised about the actual calculation of the bit strength of MLChem. I don't particularly follow the arguments, but I think there is sufficient arguments that it might be prudent to just avoid the issue entirely by staying with 768.
So I raised this issue on the issue tracker, and looking at this table and having sort of thought over it for a while, I think I'm comfortable with where it currently stands. I just wanted to make sure people were aware of it. I mean, the way that I would argue that what we've landed on is for the lattice-based crypto, we just have open questions. As Andrew said, like there have been enough questions raised about whether the post-quantum stuff actually works. We wouldn't want it to be significantly worse. But for the SLH work, it seems people seem confident that that is actually the 128-bit level. We can sort of leave it there. So I think I'm okay with it. I know I raised it. I apologize if this has dragged the group down, but I'm okay with it as it currently stands. And this table actually is very helpful for me in thinking about what we're doing with the levels. So
nothing to be sorry about. If everyone is agreeing, I will probably then report back on the issue itself with bringing this table also there and making sure that the argumentation that I just made also appears there, so that it's archived and it's kept for future reference. Okay. Next issue, and this is probably the hottest topic we have for today. That is whether we should bind the PQC encryption to V6 keys or allowing it with V4 keys. We already had this discussion at IETF 119. On the list, there was also a pretty interesting discussion. And this is not about discussing whether we should allow it with V3 or V6 PKS that's already, that seems to have reached sort of consensus on allowing it also with V3. The question is whether we should allow generation of V4 PQC encryption subkeys. So you can attach an encryption subkey to an existing V4 classical key. As of now, the draft allows it, and we already put some restrictions. So for instance, you cannot sign this subkey with a SHA-1 binding hash, binding signature hash. So the question that I'm trying to raise here is, I think there are in this room a few people that are of the opinion of not doing so. And I would guess that Kai, that is the biggest proponent instead of this, is not here. I would like also to bring this very issue to the OpenPGP summit, where more implementers of higher levels applications will be there. So, Bart?
Hello. So my 2 cents is that historically, OpenPGP has suffered from being too loose about what is essentially what kind of combinatorics can be done, whether that's not deprecating old stuff or whatever. But basically, the more combinatorics you have, whether it's the version dimension, the algorithm dimension, the other things, the more testing you have to do, the more you can get combinations which are insecure. And as much as in principle, I don't think there's anything wrong. There's not, assuming it could be done perfectly or close to perfectly, I don't think there's anything wrong with V4 PQC. I worry that it's just going to expand the zoo in a way that doesn't actually add to security. And the other thing is, I think it hurts the community at large in the sense that if PQC is not, I mean, personally, I think V6 has a lot to recommend it without PQC, but I think we're going to have a hard enough time getting the community to go to V6 without having a killer app, so to speak. So just from a strategic perspective, I think tying PQC to V6 and making this clearly the future is good, makes good strategic sense. And again, from an implementer perspective and other things, avoids having to support all kinds of weird combinatorics. Like the worst case scenario, I think, is that, maybe not the worst case scenario. The worst case scenario is people just stay on V4 and never adopt PQC at all. But the second worst case scenario is people never adopt V6 and just do V4 PQC, and V6 dies on the vine, and we don't actually modernize OpenPGP at all. And that's what I think the risk is here, because it'll be easier to just go to V4 PQC. Anyway, my 2 cents.
So note that PQC in V4 is not complete. It misses signatures. So you can do half of PQC with V4 anyway. You can't really get, it's just an optimistic kind of half, but you'll never achieve V6. Signatures still very much bound to V6 signatures and V6 keys. The other thing is, if at this point we think about competition with the V5 Libre PGP, there's the problem that they are also releasing PQC in a very similar flavor or taste than what is happening with V6. And if you think about having the same flavor on V4 and on V6, it's probably someone implementing it for V4 will already have it ready for V6, and instead of having it for V5. So I do understand the idea of having the killer app on V6, but we would not be the only ones having the killer app, and maybe someone decides to jump the bridge to V5 instead, and we get a modernization that furthers the split between the various applications. And instead, what I would propose with keeping it, like with allowing it on V4, is the fact that it would be, I would sort of call it lending a hand to the people that are not yet convinced about moving towards V6 by saying, here, V5 forbids it from using it with V4, and instead we allow it on V4. You can start using it with V4, and then once you're into the environment, you might also want to adopt V6 in our signatures. Andrew?
Hi, yeah. Just to clarify for those who aren't following it, I'm not sure if there is anybody here who isn't following it, but the way that the way that Libre is doing post-quantum with V4 is that they're allowing you to create a V5 subkey of a V4 primary key, and then they're restricting PQC to the V5 subkeys, which I think from, when we're worried about combinatorics, I think that's the one that we should really be worried about. That to me is a very fragile way of doing things, and I've mentioned this before. I think also from the point of view of people looking into the whole PGP of whatever flavor from the outside, one thing that they're going to notice is SSH has post-quantum, Tutanota has post-quantum, Zoom have now announced that they have post-quantum. We need to rule out post-quantum, or it's not just a case of, encouraging people to migrate from V4 to V6. We're basically encouraging people to use PGP at all at this point. I think the big danger that we have is that we're going to leave people behind where they have to make a big jump into V6, which we do want them to do eventually. But if we can make their jump into PQC as easy as possible, then we can very much present ourselves as, we are doing PQC encryption just like everybody else. We are not leaving people behind. And I think that should be our priority, personally. And I think the idea of using PQC to encourage people into V6, I think that still applies, as you mentioned, Aaron, about signatures. If you want to do full stack PQC signing, yes, you have to go the whole way up to V6, because there's no point having PQC signing subkeys of a V4 primary key, and it's a waste of time completely. So absolutely, when we're going to if we're thinking about the software signing and package distribution side of things, V6 is absolutely the way to go. But that's also easier to implement because it's really only back end people. It's distributions that are using that as opposed to end users, whereas the encryption stuff is much more end user facing, I think, in the short term. So I think there is despite the disadvantages, which I agree are real, I think getting post-quantum encryption into as many hands as possible, as soon as possible, should be very high on our priority list, and V4 subkeys will do that. I think that's the most efficient way of doing it. Thanks.
Bart?
I just wanted to say that I think you make a compelling case in that regard. My worry, and I'm not necessarily sure how the best way to accommodate it, is just that if we don't get good V6 adoption, that OpenPGP is going to die. There are very, very good reasons to believe that some big tech players are going to be pushing S/MIME, even in the consumer space, very soon. And anyway, it's we clearly, with the schism and whatnot, don't ever sit together. So anyway, I don't know. I don't know what the best way to do this, and I think you're right, Aaron, that we should probably talk about it at the summit. But I don't know how much V4 PQC is going to motivate people to. I worry that it's going to undercut V6 adoption, and we're going to be in a situation where the default becomes essentially V4 with PQC, which of course is better than V4 without PQC, but basically just means OpenPGP. All the problems with V4 we're stuck with forever, and the protocol itself stagnates and eventually becomes obsolete. But anyway, I don't know if this is the right way if tying them together is the right way to address that or not. It's hard.
So note that I've had an exchange with Werner as well, and I tried to see if he would come to the OpenPGP summit as well. Did not ask him to come to the IETF, since there seems to be an open field with that, but at the OpenPGP summit to discuss this, and it seems like he can't join. The only agreement that so far we could agree is, his OpenPGP, his post-quantum implementation is limited to V5, and therefore it will never conflict with ours, because even if the code point is the same, we won't allow it on V5, and he won't allow it outside of V5. I don't want to. I don't think this is the right way forward. It would have been nice to have a single, at least PQ implementation. I'll still try to see if we can get anywhere. But on the other hand, at this point, if this is the kind of cooperation we can have, I think the only solution I can imagine is to, we do our thing and they do this.
Thanks, Aaron. I think we've reached a conclusion on this one here.
Well, we've reached a conclusion on the discussion today, but I don't think
Yes.
we've reached a conclusion on the
No,
topic.
we haven't reached a conclusion on the topic. I think we had a great discussion today. I am looking forward to meet most of you, or hopefully all of you, at the meetup and have a discussion in person, having a dedicated session to this problem, trying to sort out what is actually the best solution, and in case, what would be the trade-offs we would have to do in operational complexity for it. We have here the links. They are also in the old slides. If you can't find them, please go onto our issues, open new issues, comment on the existing one. Thank you.
Thanks, Aaron. One additional comment that of the sort of outstanding argument that we've had on the list is about whether or not the hybrid PQ signature. Sorry, I'm using the wrong term. I never remember whether it's composite or composable. But the MLDSA plus EDDSA approach is needed. I think Stephen has been the largest advocate for saying that that's not something that's necessary. My sense is that everybody else in the working group besides Stephen is okay with going ahead and defining those two things. And so, Stephen, I don't know. I mean, Aaron, I see you didn't raise that point in your slides. But Stephen, if you end up sort of in the rough on a otherwise working group consensus in terms of defining the MLDSA plus EDDSA stuff, is that something that's going to, like, how are you feeling about the outcome of that? Not to put you on the spot, but.
Sure. Well, I think I'm right and you're all wrong, but that doesn't really matter, because if there's consensus to go ahead and do it, then I'm in the rough, and that's just what it is. I'm not, it has no impact. So it's just, some disagreement. Time will tell who's right and who's wrong, but if the working group have consensus on something, then what I think doesn't really matter.
I mean, as far as I know, I think we decided to go with this. To reduce the number of algorithms, do this experiment with these current code points we have, and if actually by the time we are further in this work, it comes out that this is actually the opinion of the working group changes or anything, I'm very happy to revise this and drop the ECC component of it. Let's say like this: what happened with the paper, the one published about the factorization of actually not factorization, but solving on quantum computers of lattice problems. It came out of the blue. It went out of the blue as well, but shows that someone might just come up with also a non-quantum algorithm to do so, and well, this protection would not be completely useless.
Sure, but I mean, I assume DKG was more wondering if I would cause trouble as a chair or something, and the answer is I won't.
Okay.
So, it's not how we're reassuring people.
Thank you. Yeah.
Thanks. I just wanted to make sure that we have in the note. I mean, this is one of the outstanding arguments that have been going on the list, and it wasn't mentioned in the slide, so I just wanted to make sure that it was at least raised here.
Yeah.
Sure.
Thanks.
Thank you.
I think we should move on to the next deck here, which is Andrew. Aaron, thank you very much.
Before we do, Aaron, you mentioned that there's the OpenPGP Summit coming up. Does it make more sense to try and ask people to review this document after output from that, or in the week before that?
I mean, we originally planned to publish this document by today, because also in view of this summit that is happening. So please, I am very happy if anyone can have a look before even or after with the new information we will get. I think that before would be better to show up at the summit with at least an idea of what's going on and an opinion. Then I'm happy to discuss them in person and find a common solution.
Okay, and then what's your thinking, or what's the author group's thinking on another revision timing wise?
I will be going on holidays starting tomorrow. So my opinion is that I don't think I will have much time to publish a new revision by the how to say by the summit, as I will come directly to the summit from my holidays. But I am really happy. Like, if some major discussion happens in the meanwhile, I don't need to be there to publish a version, and in case, we can always do a new tag also without me.
Yeah, I'm kind of more wondering for people who are on the list and involved in the working group who won't be at the summit. So perhaps they should expect another version before the next IETF meeting, something like that.
Oh, yeah, definitely. That for sure. Most likely after the summit, we will have some updates.
Okay, so in 3-4 weeks, something like that.
Yeah.
Great. Okay, thanks.
Andrew, I think you're up next. I can display the slides, or if you'd like to request control, I think Stephen or I can hand you off control of the slides.
Yeah, let me see. Where is request control? Oh,
I think there's a share slides button at the bottom.
Is it ask slides? Is that it?
Yes, it is.
Okay, yeah. Okay. So working for everybody?
Yep,
looks good here.
You can see it.
Okay.
Just if you let people know if you'd rather they wait till the end or jump in, whatever is your preference is fine.
Yeah, sure. So the structure of this is going to be kind of, I start off fairly concrete and then it gets woolly towards the end, and for reasons that are probably already obvious if you've been following the mailing list. But anyway, so this is an expansion of the slides that I was supposed to give at IETF 119, but unfortunately I was ill and couldn't attend. There probably wouldn't have been time for me anyway, given the other items in the agenda. But so this is just an expanded version of those slides with some extra feedback included. So as DKG, I think, already mentioned, so this is a revival of a very old idea. Daphne originally drew this up around 2001. So the basic idea is that we define a new signature subpacket, and we can use them in any kind of self-signature, but really it's going to be either standard self-certification signatures or revocation signatures. It's not particularly useful for any other kind of signature, so we call that out in the document. The kind of the wire format design, it's along the same lines of intended recipient subpackets. So we have a version and the fingerprint of the new key, which is the one that we suggest is the replacement key for the current key. There is also a subpacket version byte and a flags byte that just gives us a little bit of elbow room to define extra stuff in the future if we need to. There is one flag already defined in the flags byte in the document, and that is a specific flag to say that there is no replacement key, as opposed to leaving the replacement key undefined. But other than that, there's nothing else in there at the moment. It's just for future use. So the semantics of this is that it provides a hint or an indirection for where to look for a new key for a particular user. So if a user has a key already, but they want to roll that, they can add this essentially a notation to this key pointing or identifying the replacement key so that people can follow that and find the replacement key by whatever means. It also defines a preference ordering between the two, and that's kind of implicit in the fact that it is an indirection. But if, for example, a correspondent has both keys, how do they choose between two keys for the same user? If there is a replacement key subpacket, that essentially defines a preference ordering subject to them both being already valid and verified keys for that user, again, by whatever means. And this is where we start getting into trouble, because this indirection does not contain in itself any kind of trust relationship. And that's deliberate because of the design. The design uses fingerprints as identifiers rather than signing over an actual key. I'll get into that in a second. But the standard, assumption of how this would be used would be if I, as a key owner, want to roll my key. So I currently have a V4 RSA 4028 key. I'm very, very stuck in the past, but I want to bump this up to a post-quantum key, say a V6 post-quantum key or something like that in the future. So I create this new key, and it's probably a good idea for me to certify that new key with my old key to provide some kind of relationship to start with. And then I make a new self-signature on my old key, which includes this replacement key subpacket. And this replacement key subpacket identifies the new key. Now, at this point, I can do one of two things. I can either soft revoke my old key now, or I can not. Now, if I do soft revoke my old key, I can include the replacement key subpacket in that soft revocation, because it's a valid subkey in that context. Sorry, a valid subpacket in that context. The reason I don't mention hard revocations is, of course, if you hard revoke a key, everything about it is suspect, including subpackets. So it's pretty meaningless. But with a soft revocation, what I'm saying is that, as I'm saying, do not use this key anymore. You must use the new key. But in the case of a V6 or a post-quantum transition, not all of my correspondents may be able to understand the new key. So I may want to leave the old key still valid and have the new key valid for some transition period between the two. And so in that case, I would not soft revoke my old key, or at least I wouldn't revoke it yet. I might do it at some point in the future. In either of these scenarios, my correspondent would see an updated version of my old key. If they've refreshed it, say, from a key server, then they would know to go and find the new key. And then this is where it starts to get complicated, because we don't have an implicit trust relationship, we still need to verify the new key by standard means, by whatever other means we would normally use to perform a trust calculation against that key. In some scenarios, this is fine. This is not a problem. In other scenarios, this actually might get problematic. So this is where we start to ask how far the scope of this draft should be. So calculating the trust on this new key is non-trivial, and the thing about trust in PGP in general is it's non-trivial. And the initial draft of this particular document basically tried to defer any discussion of trust to other documents or other places. But after discussion on the mailing list, it became pretty clear that we couldn't avoid the issue, and we were going to have to deal with trust calculations, or at least call out, some recommendations for trust methods here. So the scope has expanded a bit. So in the current draft, we do specify a couple of usage scenarios. They aren't fleshed out in full, but they're kind of skeleton usage cases. And I'm going to go through a couple of them here, and then I'm going to mention one that we have not really discussed, because it does expand the scope of this document significantly. And that's something I'm unconvinced we need to do, but we might need to do it. So the main issue here is that the replacement key subpacket itself is cryptographically weaker than a certification, because we're only signing over the fingerprint of the new key. We're not signing over the actual new key itself. Normally, if we make a third-party certification over somebody else's user ID, it's also signed over their primary key, and that's a particularly strong cryptographic binding. But because we're only signing over the fingerprint, there are concerns that, what if a particular fingerprint algorithm is deprecated in the future? Will we have problems with SHA-2 and have to migrate to SHA-3? These issues come into play where they don't come into play for a standard certification signature. Now, one way of getting around that would be to actually sign over the key material of the replacement signature, but then we run into other problems. The first problem is that, particularly in the PQC world, the new key might be quite large. And also the new key may go stale. So, for example, the new key may itself be revoked for whatever reason. So we don't gain much, because even if we do have a full copy of the new key inside the old key, we're still going to have to go and refresh the new key to see if there are any revocations on it. And we're adding a lot of complication for not much benefit, really. So we've decided that key trust needs to be defined by some other mechanism, not just the replacement key subpacket, however it is defined. So there's three ways to do that. We can do it the Web of Trust way by getting certifications over the new key to match the old key, or we can use something like WKD or AutoCrypt to distribute the new key in a way that has implicit trust. Or we could define some kind of specific certification where we could sign using only the old key over the new key in such a way that we can transfer full trust from one to the other. And this is a novel mechanism that we probably should think about a lot more before we try to define it. So I'll run through the first two quickly. We've discussed this on the list at length. Sorry, Daniel, you want to jump in?
Yeah, so I just wanted to jump in and observe that one of the issues from the working group perspective is that we have not managed to get a clear working group consensus on adopting this draft. Mm-hmm. So I really appreciate your going into the detail, and this detail has come up because of the complexities that arose during the adoption call. Mm-hmm. But I want to flag in particular for folks that if you're concerned about adoption, if you think that these things are worth working on, that we have this baseline question of adoption, and for that we need to hear a clear voice from the working group that says, yes, we want to work on it, and we think this document is heading in a direction that we want to work on. It doesn't have to be that it's perfect right now. I just want to re-raise the adoption questions in particular.
Yeah.
Thank you. Sorry.
No, you're fine. Sorry. Yes, I probably should have called that out earlier. I was planning to call that out at the end, but yes, thank you for the reminder. Bart?
I can wait until the end. Sorry, Daniel jumped in, so I thought it was time for questions, but I'll stop.
Okay, no problem. Daniel, you're muted. Sorry.
Sorry about that. Yeah, I did want to respond to Daniel's point by saying that I do think it's useful to talk through these issues before or during the adoption call, let's say, because my question on the mailing list was kind of, if we don't think about the trust questions, like is this draft useful, right? Does it serve the purpose that we think it does or should? So I think having this discussion might help resolve that question, at least for me.
Okay, thank you. So yes, so in the next 3 slides, I just want to quickly go through the issues with trust that have been raised on the list, and I suppose at that point then we can decide. It gives people more context, I suppose, as to how this would fit in to the wider kind of trust concerns. It's hard to talk about trust specifically when we don't even have an agreed kind kind of mechanism for trust just in general in OpenPGP. It does tend, we have the web of trust, but it's still very woolly around the edges in some ways. There have been some attempts and some draft documents even made to try and pin them down. So I'll try and keep this, limited to just what applies to this particular draft. And we can worry about, the wider issues of trust at some other point. So, yeah, so to get back to the list discussion, so one of the issues that was raised is about transition documents. And the way the transition documents have been done in the past is people basically write something out in human readable text to say, this is my old key, this is my new key, I would like you to sign my new key, please gather some signatures. So the way that this would help automate that particular process would be if I create the new key, and I, as discussed earlier, and add the replacement key and do not revoke, which was one of the alternatives that I spoke about in the previous slide. I can then send both of those keys to my existing certifiers over my old key and ask them, please sign my new key. I see you've signed my old key. And then if they sign my new key and send it back to me, I can publish the new key with all of the third-party certifications on it, hopefully that roughly match the third-party certifications on my old key. And that basically implies that anybody who trusts my old key probably should trust my new key, because the same trust calculation will end up being performed on both keys. So they should come out equivalent. So once both of these keys are then trusted, then the replacement key subpacket indicates an ordering on the keys that are already trusted, so that the new key is preferred over the old key. And then at some point, I can then revoke the old key, depending on how long of a transition period that I want. The other method would be to use some kind of trusted or implicit trust channel, such as AutoCrypt or WKD. So what I could do is I could distribute both keys via the same channel. So if you would trust my old key, if you receive it over AutoCrypt, you would automatically trust my new key if you received it over AutoCrypt, because it's the same thing. And similarly with WKD. But again here, the replacement key subpacket indicates an ordering. So it says, this is the one that I prefer if we are in the have not revoked the old key scenario. So say, for example, post-quantum migration period. Now, that does require that whatever your distribution channel is, it has to be able to serve both keys. WKD, as currently defined in the current draft, does not allow for multiple keys. But we can look into that. That's a matter for another document. The third way of doing it, which is what Daniel Huggins and I spoke about briefly on the list, was how do we infer trust based purely on a signature by the old key over the new key without having to involve third parties and getting all of the certifications? Can we not just bind one to the other some way and just say these two are equivalent? So one idea would be, if the old key certifies the new key and they have matching user IDs, then obviously they're the same person. But that introduces wrinkles into your web of trust calculations, because generally in the web of trust, if A signs over B, B will normally get a lesser trust value than A, because you have to not only trust A, but you also have to owner trust A for the signature over B to be considered in your trust calculations. And you may be using a partial trust model that requires more than one signature. And this gets really complicated with existing web of trust models. So overloading the meaning of something that already exists in these kind of narrow circumstances might be confusing. It might lead to unexpected results. So I would be of the opinion that if we are going to do this, we should define a new mechanism for it. So either we could define a completely new signature type, which might be overkill, or we could use an existing certification type and then add a subpacket in order to distinguish it from, an ordinary kind of certification. One other thing that we should consider also is the cryptographic strength of this kind of certification, because again, generally as you go down through your web of trust, your trust value decreases. And the places in PGP where we assign an equivalent trust value to something generally involve much stronger certification. So for example, if I have a primary key that can sign on my behalf and I have a sub key that can sign on my behalf, we typically require that the sub key also has a back signature over the primary key in order to establish that equivalency, because otherwise people can do nasty things like stealing other people's or sub keys or pretending that somebody else's signature is their own. So we need to consider that as well if we're going to go this way. Now, I'm going to go slightly off the reservation here. I did also have a discussion with some of the guys who work on the Ariadne, also known as key oxide protocols. And one of their issues was actually redaction of old user IDs, essentially. And because there's no way that we can revoke old user IDs while also redacting old user IDs, because they have to remain available for the signatures to verify. There's an issue with privacy that might arise if we have quite strong certification bindings. One thing that we did suggest was that maybe this replacement key mechanism could also be useful for the Ariadne protocol, where instead of accruing multiple user IDs on a single PGP certificate, you actually can roll your PGP primary keys over time and put your new proofs on the new key, and then eventually at some point revoke and clean up the old keys in order to maintain some semblance of control over your own privacy. Now, one thing that they did also mention was that this user history for their means should be walkable in both directions. And having a trust relationship of A over B does allow, in principle, particularly if it's certification, somebody to take key B and then identify that back to key A. And that raised an issue, again, in my head about maybe people don't want this replacement to people, maybe people don't want others to be able to follow that replacement chain backwards. So I'll skip over this slide. Basically, I won't read through the whole thing, but the general idea is that there are different places where we could put these certification signatures. If we have some kind of trust equivalency signature, should we distribute it on the new key or should we distribute it on the old key? Because from the point of view of calculating the trust, you're going to have both keys available anyway, so it doesn't really matter. But depending where you distribute it also has implications for privacy, which are not well explored and may be problematic in some cases. And we are getting into the weeds here. But the general thrust of this is that there are options here for how we determine the trust of a replacement key, but they all come with trade-offs. And if we do adopt this, there is more work to be done in terms of teasing out the implications of trust and how trust can be inferred on the new key by some, what are the trade-offs between the cryptographic strength and the privacy implications. So yeah, just a couple of open questions on the list. I think I've gone through them already. So the first one is, what implications does this have for how people do transition documents? I don't think very many people actually do have transition documents. Certainly in the wider kind of non-expert community, I don't think they're well known or well understood. The web of trust itself is not particularly well known or understood. And most people who have keys have no certifications over them. So it doesn't really make that much difference to them. But for those people for whom this kind of certification rollover is important, we do need to be sure that this does meet their use case. And I suppose one outstanding question is there a standard transition document use case? I know Simon has provided his own. Is that typical of other people? I don't have enough information to really make a decision. One issue that Daniel mentioned was that, how does this play into TOFU, particularly in an autocrypt scenario? If you receive an autocrypt key, does this make any difference to whether we accept the new key delivered over autocrypt or not? Should we just take what autocrypt gives us and just, and just use it? Is that TOFU or is that YOLO, as DKG puts it? I think it's somewhere in between, maybe. And then one suggestion that Bart had was that the single key limitation of WKD, which I mentioned a couple of slides ago, we could fix that in a new HKP protocol, but that is a separate document for another time. So I will finish up here. These are the links to the usual places. So any questions? Justus, hi.
Hello. So I have like 3 comments. First, whenever you define a new OpenPGP subpacket, please make sure to specify what it means to have more than one subpacket.
Mm-hmm.
I think that would be rather useful in this case to have a traditional v6 key and a post-quantum v6 key, for example.
Okay.
I'm not fond of the version field and the flag field.
Mm-hmm.
I think we should rather slim the packet down, and if it doesn't fit future use cases, make a new subpacket. There are plenty of free subpacket slots. Because I'm worried how that interacts with subpacket criticality. For example, should a critical subpacket make the signature verification fail if one of the bits in the flag field is set? That we don't understand. Probably, but it's complicated.
Yeah, that is. I think that's a general problem really with critical subpackets. It crops up quite a lot. So yeah, it is definitely worth exploring that. Yeah. Sorry, you had one more?
Yeah. Third, you mentioned this trust delegation mechanism. I believe that is already present in PGP. You can, or we believe you can make a direct key signature and include a trust subpacket. And this is like a delegation to the new key.
Yes, but you still. Sorry, go on.
Well, the neat thing is that downstream consumers will, if they happen to have a trust path to your old key, then this will extend to the new key seamlessly.
So the trust subpacket, I think you still need to have owner trust of the old key.
Owner trust is a GNU-PG packet. It's a GNU-PG concept. That's kind of special to how GNU-PG computes the web of trust.
Yeah, but you see here we're getting into how different implementations think of the web of trust, and I think it gets messy then.
So just as a chair interrupt, we were down to like 12 minutes.
Sure.
We have a queue of a couple of people. So I think the adoption call is the main thing. So I'd like if people would just give an opinion about adoption, and we'll have to process on the list and then move on to Daniel's, I think. So Daniel, did you want to talk and consume your own time?
Yes, I will take 1 minute of my presentation time to say that if we include the trust topic into the scope of the document, then I would be in favor of adoption, although I think we should consider like trying to solve both at the same time somehow, like pointing users to the new key and delegating trust, if we can do that in a single sub packet, or if it's already possible, like Eustace says, then maybe we could write down how to do that without defining any new sub packet. Or combine the two somehow. So I mean, that's a bit of a vague vague idea of what the draft should be, but if we are open to considering that, then I will be in favor of that.
Okay, so the call for adoption is open on the list. I can't remember what the deadline set for that was, if there is one, but
it's long gone. It's
okay. Well, yeah,
yeah.
I guess we should add another week or two from now, and then we should encourage people to express their opinions on it, and they can use this presentation then as material to form opinions if they haven't already. I think that sound like a way forward.
Okay. Yep, I'm happy to leave it there unless.
Okay, so yeah, as chairs, we'll send a renewal of the call for adoption, give it another week or so, or 2 weeks maybe, and ask people to express opinions about that, and point them at this recording.
Sure. Okay, thank you.
Okay, thanks, Alex. Thanks. And Daniel, do you want to? Oh, yeah, there we go. Okay, and we're at 9 minutes, so I guess as speedy as we can be.
Yes, I'll do my best. Thanks. All right, so I've already presented about persistent symmetric keys at previous IETF meetings, so I will fly through the introductions, and then if you have any comments about the concrete description, please interrupt me during the presentation. So yeah, very briefly, we would like to allow users of OpenPGP to encrypt messages and files and so on using a long-term symmetric key that they store encrypted with a password, rather than, for example, encrypting individual documents with a password, or encrypting documents with your own public key, which is rather common today, but is obviously inefficient, especially once we go to post-quantum encryption. And similarly, we would want to allow creating attestations using a symmetric key, for example, to record the result of a signature verification, so that you don't have to verify the potentially post-quantum asymmetric signature again every time that you open an email or a document, for example. So how do we roughly do that? Well, we notice that the semantics that we want are still those of PKESK and signature packets, even though the name of the PKESK packet doesn't really match. So we propose renaming it, and also retconning the public key algorithms registry to persistent key algorithms, and then define 2 new persistent key algorithms, namely AAD and HMAC. Obviously, the details are up for discussion, and even the retconning idea is up for discussion, but that's what the draft does right now. So this is roughly what the current draft says, except for the algorithm IDs. But the way we've implemented it right now in our experimental implementations is with the 2 experimental algorithm IDs, 100 and 101. The first one for AAD, which specifies a symmetric algorithm to use in the public key, and a secret key. It has a key material, and then we have this the seed and the hash of the seed, which is kind of meant to bind the secret key and the public key together, so that when you decrypt a secret key, you know that it belongs to the public key. that a message was encrypted with, or belongs to that fingerprint, let's say. Although I'll get back to that particular detail. And then the PKSK has the AED algorithm and the IV in the length and subtext, although we'll also propose some changes to that. And then the HMAC has very similar the hash algorithm and the key material in the private key and an authentication tag in the signature, symmetric signature, let's say. So then regarding the algorithm IDs, maybe the least important detail, but I would propose that we eventually choose 128 and 29, such that you can use the first bit to determine whether it's a symmetric algorithm. And then if we ever want to, we could, define 130, and then, or we might even want to define a new range for experimental symmetric persistent key algorithms, so that you can know that they're symmetric, even if you don't know the algorithms. One other change is during IETF 119, or when making the slides, I realized that it would actually make a lot more sense to put the AED algorithm in the public key, so that it's so that you can only use the key with one AED mode. Otherwise, we would have to probably introduce an HMAC step to have key binding, which is a bit more expensive. And if we put it in the public key and you encrypt the private key using AED, then it's bound to the public key material, so you can know that the key material is bound to the AED algorithm. Then one other detail is I realized that if you do that, then the key material is already bound to the public key material, as I said. So we could just put a fingerprint seed in the public key material, and that should be enough to bind them together if we require that you use AED encryption, meaning S2K usage octet 253 when encrypting such keys. And then I realized that the length is a bit redundant since the ciphertext is the last field. So if we put that all together, then this would be my actual proposal, rather than what the current draft says. And this is more or less the state on GitLab right now. So I'll link to that in the next slide. So if you all agree with these changes, then, and if you agree with to adopt this document, obviously, then I will propose that we publish the version from GitLab to the OpenPGP scope. But obviously, if you have any comments about any of these details or any other details, I would be happy to hear your feedback. Yeah, here are the links to GitLab. Yeah, we have experimental implementations in OpenPGP.js and GoCrypto that still need to be updated to the details that I described now. But other than that, they essentially implement this this version. So yeah, let me know if you have any feedback or if you agree with these changes. Obviously, we only have 2 minutes left, but I'm also happy to take feedback on the list or anywhere else. So yeah, thanks. Let me know if you have any feedback or questions.
Thanks, Daniel. In terms of the call for adoption, I want to just remind folks that what we're aiming to do here is produce interoperable mechanisms. And in some sense, the use cases that Daniel has presented are for what might be a single implementation and might not be interoperable in that sense, might not need interoperability. I will flag with no hats on that for me, I actually think there is still an interoperability question here because we have we have stored artifacts, and then you might want to use a different implementation to access the same stored artifact. And I think that's that's the reason why we would want to consider adopting this if the working group is interested. But that would mean that we would want to ensure that there are at least there's at least another implementation that's not coming from Proton that would be interested in actually trying to make this stuff work. So in terms of the adoption call, please think about whether, as an implementer, these are things that you would be willing to do to be able to interoperably handle stored data sets. Just wanted to flag that as an adoption development.
Great. So there's an ongoing adoption call for this on the list. Relatively recently, I guess it still hasn't got a huge amount of feedback since the adoption call. But so I guess the action on the chairs here again is probably just to point people at this presentation, maybe the previous one as well, and try and solicit opinion on the list about adoption. Does that sound right? Okay. And again, I forget what deadline was set for that, but we can shift it anyway because it makes sense given that there's an interim and people have something to look at that they can think a bit better about it. So in the 0 minutes we have left, I don't know if anybody wants to jump in the queue and express opinions about adoption of this or questions quickly. Don't see anybody in the queue, so I guess we have we also have 0 minutes for any other business. Any other 0 business? DKG, are we?
I think we're at time here. I appreciate the presentations and the commentary and interactions. If you chew over what we talked about today, please, and you come up with thoughts about it, please share them on the list. And for those of you who are coming to the OpenPGP email summit, which is coming up soon, I look forward to seeing you there. And I'll make an effort to report back from the summit to the list as well.
Great, thanks. And Paul, I'm not sure if you were there at the start or not, or if you have any kind of AD kind of wisdom to impart?
No, I was not there at the start. Sorry, I was like 30, 40 minutes in late.
Okay, so we mentioned the Auth 48 on the crypto refresh is in work, and otherwise, any other AD type news you want to impart?
No, but yeah, the Auth 48 is a huge one. It's one of the, I think, the biggest I've ever seen. So it's going to take some time. And as an author, I responded, but I definitely need the help of some of the other authors on this.
Yeah, so DKG mentioned that at the beginning. All right. So
okay, awesome.
Great. So with that, I guess thanks to our note takers. You look like you've done a fine job. There's a couple of actions on the chairs to poke things along. And I presume we're going to be requesting a session in the Vancouver IETF. So we should get to do that as well. Anything else we've forgotten or I've forgotten, DKG?
I think that's it. I think I may have already requested the session at the Vancouver IETF, but I'll double check to make sure.
Okay, great. Great, and with that, I guess we'll take those actions, follow up as we will, and see you on the list. And thank you for turning up today, and thanks to people for presenting, our note takers, and everybody else.
Thanks all.
Thanks, and bye-bye.
Thank you. Bye.
Bye.